A very good morning to Dr. Arif, fellow friends. We are from Group H. Our title for the mini project is Image Encryption using the random scrambling and XOR operation. So my name is Encryption, BS221065111, and my teammate, who is Medical Jones Pomano, BS2211000, and Muhammad Adili, BS2211046. And No Zarifa, BS2211003X6, and Brian Ong Chen, BS221065526, and Mama Izam, BS221100325. And last but not least is Mohas, BS221104322.
Hello, my name is Muaz Amin Shah bin Kamaruddin. Number is BS22110432. And today, we are going to go through the research paper details first. And let's go for it. The research paper title is Image Encryption Using Random Scrambling and XOR Operation. The authors' name are Rinki Bakshwar, Department of Computer Science, Lakshmi Narayan College of Technology, Bhopal in India. Assistant Professor Vijay Kumar Trivedi, Assistant Professor Department of Computer Science, Lakshmi Narayan College of Technology, Bhopal in India. Professor and Head of Department Vinay Richarya, Professor and Head of Department of Computer Science, Lakshmi Narayan College of Technology, Bhopal in India.
So, good morning, everyone. My name is Muhammad Izam bin Dani. So, today I'm excited to share with you guys about research endeavor focused on enhancing image security in our insanely digital world. So, actually, my part is explaining about introduction. So, our research explore novel encryption techniques to address the growing need for enhanced image security, emphasizing the limitation of existing algorithm in safeguarding multimedia data and the needed for innovative approach to protect confidentially imaginary. So actually in this part, there are three main points that I want to mention. First is importance of image encryption. So actually in this part, image encryption ensure that only authorized individual can access confidential or private digital data. So vital in our interconnected world where vast amounts of sensitive information are exchanged. So next is challenge with multimedia data. So actually multimedia data such as image and video pose unique challenge due to redundancy and correlation between pixel value, making standard encryption method vulnerable to attacks. So finally is limitation of existing encryption algorithm. So actually traditional encryption algorithm like DES, AES, RSA, and IDEA designed for text data, so may not effectively secure multimedia data due to their inability to address its unique characteristic and security requirement. So finally, we move to objective of the paper that my groupmate will explain, Miss Zarifa. So thank you.
Based on this research, the objective that we get is to design and implement an image encryption and decryption algorithm that provide confidentiality and security in transmission and storage of grayscale image-based data. Secondly, to reduce the correlation between neighboring pixel in the image by shuffling the pixel using a scrambling technique. And the third one, to encrypt the shuffle image using XOR operation with 4 8-bit keys to ensure strong encryption. And the last one is to test the proposed encryption algorithm on different grayscale image and evaluate its effectiveness in terms of lossless encryption, maximum distortion, maximum performance, and maximum speed. That's all about
Next we will move on to the explanation and demonstration of the purpose technique, which is the image scrambling using the XOR operation. So first of all, we will see the algorithm one, which is the encryption algorithm and set aside. In the image encryption process, start with selecting a grayscale image X of MN, pixel size with L bit per pixels, which is to be converted into the grid form before transmitting to the other end. So our input is a grayscale image X, with the desired output is a cipher image, which is represent XXC. So first of all, we will input a grayscale image X of MN size with L bits per pixels. Then we'll decompose a gray image into the L bit plane image, which is the image XL equal to block L times X. So if the XMN is a pixel located at the MN, then the L bit of XMN we will get the 2 transmitted, which is 1 if the XMN divided by the 2 mod 2 is equal to 1 or 0. So we will transform the bit plane image XL into the 1D vector VL. So after we transform the bit plane image XL into the 1D vector V, we will need to use a random natural number generator and choose a couple of differences to produce a 2 random sequence, which is RS and RD. So that we will merge the scrambled bit planes image according to their original levels of bits plane and get a transform image, which is XT. So XT, according to the formula, is summations from L equal to 1 until L minus 1 blocks times X. So for the pixels at position Mn, we'll also have the transformed cipher image xt Mn is equal to summation from L equals to 0 until the L negative 1, 2 times X Mn. After we merge the scrambled bit planes image according to their original levels, we need to transform the image, then divide it into 2 pieces characteristic blocks. Each block represent the Bij of the transformed xt cipher image is encrypted using the XOR operation by 4 8 bits key, which is K1, K2, K3, and K4. So for the image P, row 1, column 1, using the XOR operation, we need to use the key 1. And row 1, columns 2, we need to use the XOR operation with the key 2. And row 2, columns 1, we need to use the XOR operation with the key 3. And last but not least, row 2, columns 2, we need to use the XOR operation with the key 4. So where the Pij is the pixels value at the ij location in block result image called by the cipher image xc is ready to send to the receiver side. So this is all for the algorithm equation. So at the right side, we can see the flow chart for the equation algorithm at sender side. After the sender send the equation image to the receiver, so we need to decrypt. So how the decryption algorithm at receiver side? So the input is a grayscale equation image xc of nn pixel size with LB per pixels, which is to be converted into original form before sending. So for the input is cipher image, which is the xc, and output is a grayscale image x, which is the original image. So for decryption, the cipher image xc is first divided into the 2 pieces times 2 pieces blocks, and each pieces of every block decrypt using the XOR operation with the key K1, K2, K3, and K4. So same as the equation. The equation is the pieces row 1, column 1. We're using the XOR operation with the key 1. And row 1, column 2, we'll use the XOR operation with the key number 2. And row 2, column 1, you use the XOR operation with the key number 3. And last but not least, the pieces row 2 and column 2, we will use the XOR operation with the key number 4. So after we encrypt using the XOR operation with the keys K1, K2, K3, and K4, the decrypt image represent at the XD is then decomposed again into the L bit planes image by using the formula used in equation number 2. After that, we'll transform the bit planes image, which is the XD powered L, into the 1D vector form, which is VL. Then we use again the random natural number generator and use the same of couple of seeds used in the encryption time to produce the same random sequence RS and RD with the same length as V, and anti-scramble the 1D vector V. So last but not least, we'll merge the anti-scramble bit plans image according to the original levels on bit plans again and original image. So this is all for the decryption algorithm as the server side. And at the right side is the algorithm flow chart. So this is a flow chart for the decryption algorithm and receiver side.
Hello, my name is Muhammad Azizikram bin Sarudin. Now I will continue with my part, which is example. Based on the article given, there are four examples given, which is bit plane decomposition of image, reconstruction of image, random scrambling and anti-scrambling of image, and bit plane scrambling and anti-scrambling image. We move on for the first example, which is bit plane decomposition of image. The gray level of every pixel image explained by the multibits, and every bit is create the same level as the binary plane. So that's why it's also called as bit plane. Now, for the example, let X is an M times N digital image with L bits, XL which L is 0 until L. Let B times power of L be the operator of bit plane decomposition. Decomposition of L bit plane is expressed by XL is equal to BL times X. Okay, if XMN is a pixel located at MN, then the L bit of MN is XL with MN equal to BL, and BL is equal to 10 if XMN over 2L mod 2 is 1. Otherwise, it will be 0. Now we move on for the second example, which is reconstruction of image. Suppose that b power of negative 1 1 dot are the image reconstructor operator. We have here that xt, which is x total, equal to total of b minus b power of minus 1 l multiplied by xl from l equal to 0 until l minus 1. For pixel at position mn, we also have x total mn equal to the total of 2l multiplied by xlmn from l0 to l minus 1. Now we move on for the third example, which is random scrambling and anti-scrambling of image. Based on the article, it states that these methods are more stable and safer than the classical method. The method begins by transforming an m times n digital image x into a 1D vector, which is v. Then use a random natural number generator and choose a few numbers. By then, we produce two random sequence Rs and Rd with the same length as v and scramble the 1D vector v as follow. VRSI arrow symbol, VRDI, which is I is equal to 0, 1, 2, 3 until m times n minus 1, where the arrow symbol denotes the interchanging of two relevant elements in sequence Rs and Rd. Last but not least, the fourth example shown in the article, which is bit plane scrambling and anti-scrambling. It's used to transform the bit plane image XL into a 1D vector V, L. It's similar to the third example. It uses the similar formula, I guess, and that the rule of bit plane scrambling and anti-scrambling will be rearranged as VLRSI interchange or the arrow symbol VLRDI, which I is 0, 1, 2, 3 until m times n minus 1, and L also equal to 0, 1, 2, 3 until L minus 1. That's all for the example.
Hello, my name is Benicol Jones Manul and I'm going to present the result of encryption and decryption image. We implement our algorithm in MATLAB running on Windows platform and use 7 8-bit grayscale image of size 256 times 256 like in the figure below. The encrypting process of the image by taking the initial condition, the encrypted image hides the totality of the information contained like in figure A and C. Figure A is the original image, and when you scramble the original image, will result in figure B. And when you encrypt the scrambled image, result in figure C. Figure D is same as figure B because when you decrypt the encrypted image, it will result in the original image, which is in this case figure B. The encryption of an image involves random scrambling and XOR operation, with the distribution of intensities varying with the initial condition value. So when a different initial condition value used will result in a different distribution of intensities. When the decryption process is done with the same initial condition, we recover the original image, like in figure E. So figure E is figure A, because when you unscramble the scrambled image, we will retrieve an original image. And if the key used in decryption process and encryption process is equal, the original image will be recovered. And there are also histogram graphs. We can witness here that histogram of decryption image is same as histogram of the scrambled image, and the histogram of anti-scrambled decrypted image is the same as histogram of original image. The table here shows a histogram deviation calculation for flower 1.5716, bud 1.4615, Lina 0.7257, hours 0.7165, nature 0.6895, explain 0.6103, airplane 0.8335. For this last table, shows an average correlation coefficient between pixel values. For Lina, chaotic Baker map 0.3247, affine transform XOR 0.5088, proposed method 0.14. Explain, chaotic Baker map 0.8762, affine transform XOR 0.4983, proposed method 0.28. Airplane, chaotic Baker map 0.2877, affine transform XOR 0.2873, proposed method 0.04.
Hi, I'll talk about the conclusion for image encryption and decryption algorithm. It is designed and implemented to ensure confidentiality and security during the transmission and storage of gray image data. Next, this scheme presented in this paper has a simple implementation module that ensure multiple criteria, including losslessness, maximum, distortion, performance, and speed. Okay, the proposed encryption method in this study has been tested on gray images uh, as presented before. That's all for me. Thank you.